The binomial theorem can be a tedious theorem to implement. That's why today on Math Hacks, I am showing you the techniques that I use to simplify the process and stay organized. In today's tutorial, you'll learn not only what the binomial theorem is, you'll also learn about some quick and easy checks you can use to avoid errors, and a shortcut that will greatly reduce the amount of computations you need to make. When you crack open your textbook or do a quick Google search for the binomial theorem, you're going to stumble across a formula that is a bit confusing the first time you see it. So we have a lot going on here in this formula. We have sigma notation to represent summations. We have the choose formula from combinatorics. We have all sorts of exponents and variables and factorials going on. And you're thinking this looks like a lot of work just to multiply some binomials together. But bear with me, it will pay off in the end. Plus I'm going to show you some shortcuts to help you get through what could be a really long problem. So let's go ahead and do an example. Let's expand x minus 3y to the fifth. So what this means is that I want to multiply x minus 3y with itself 5 times. And if you've ever multiplied out binomials, you know that for the first 2 or 3 binomials you multiply together, it's not too bad. But as we add on this 4th and 5th and so on, it can get pretty nasty. And that's something we really don't want to do. So that's why we have this formula. So to apply this formula, the first thing I want to do is figure out what my a and b are. So a is the first term. So in my binomial here, a will be x. So I'm just going to write a underneath it. And then my b is going to be negative 3y. And it's important that you take that negative sign along with you when you do this expansion. The third thing I want to look for is the power. So the n. In this case, my n is 5. So what we've found is that a equals x, b equals negative 3y, n equals 5. So for the first term in our binomial expansion, I'm going to start with k of 0. That's what this sigma notation here means. And I'm going to plug in these values for the rest of my variables and use 0 for k. So the first term is going to look like, so what I have here is 5 choose 0 multiplied with x to the 5 minus 0 power and negative 3y to the 0 power. Notice how I have the parentheses here and have the exponent on the outside. That is a really important step because you want to make sure that this exponent is being applied to both the coefficient and the variable. Now what we would do next is go through and increment k to 1. So now I'm going to do the exact same thing and plug these in, except for put 1 for k. Since we're going to have 6 of these terms, you can already see that this is going to take a couple of rows if I start writing it horizontally. So what I want to do here, just to stay organized, is I'm going to write each term in a column as if they were mini problems. And then I'm just going to add together all of the answers to those miniature problems. So below this, I'm going to write out the second term. So again, these values are going to stay the same, and I'm going to use a k of 1 this time. Now you may notice a little pattern here. We have 5 minus 0 in this first one on the exponent, which is 5. And we have 5 minus 1 here, which is 4. So what's going to happen here is the first term as we go through is going to count down from the degree, which is 5 in this example. So it's going to count down from 5 to 4 to 3 to 2 to 1 to 0. And our second term is going to count up from 0 to 5. You may also notice that the k value is going to be incrementing each time by 1. So instead of going through this process of entering everything into this formula each time, it's really easy to make mistakes that way. So what I would recommend doing here is writing out the parentheses, replacing the 5, the x, and the negative 3y for the rest of the terms. So you're always going to have one more term than the degree of what you're expanding. So since this is 5, I'm going to have 6 terms. So I'm going to just quickly write out 4 more of these below it. Okay, so now that I've copied down the parts that are going to remain the same in all of these little miniature problems, I can go ahead and increment my numbers. So let's start with the k value. So the k starts with 0, and then it goes to 1. This one will be 2, 3, 4, and 5. And you should end up where the last two numbers are the same. Now let's go ahead and do the powers on x. So I started with 5. 4, this one's going to be 3, 2, 1, and 0. And you should always end with 0 in this column. And then for the last one, for negative 3y, we're counting up from 0. So we have 0, 1, 2, 3, 4, and 5. And what I like about doing it this way is it prevents me from making some really silly transcription errors when I try to just write it all out one at a time. Another quick check that you can do just to make sure that you haven't made any errors is the powers on your two terms should always add to the power that you're working with. So 5 plus 0 is 5, 4 plus 1 is 5, 3 plus 2 is 5, 2 plus 3 is 5, 1 plus 4 is 5, and 0 plus 5 is 5. Now that we have outlined all of the little miniature problems we need to solve, the next thing to do is to simplify them. So we're going to solve each of these problems. So I promised you shortcuts, and I have another really important shortcut here. So the next thing we need to do is take care of each of these little problems. Now, the first part of the problem is to solve 5, choose 0. Now that comes from our combinations formula, which we have outlined up here. And what we would do is we would plug in 5 for n and 0 for k. So we'd have 5 factorial over 5 minus 0 factorial times 0 factorial. And we would go through and apply the factorials, cross cancel, and get an answer. And if that is the way that your teacher is requiring you to solve these problems, then I would definitely do it that way. If you need a little more explanation of the combinations formula, I have another tutorial on that. But today I'm talking all about shortcuts. So the shortcut that you can use here is instead of using the combinations formula, which our theorem tells us we're supposed to use, we can use Pascal's triangle. So the first thing I need to show you is what Pascal's triangle is. Now it's really easy to make. What you do is you start with a 1, and then below it you write 2 other ones. And on the outside of each row you're going to write a 1, so we'll put another set of 1s here. And then in between I'm going to just add together the 2 numbers above it. So I get 2. Let's do another row. So I'd have 1 on the ends, and then I would add like this. So 1 plus 2 is 3, and 2 plus 1 is 3. So again, another row, I'd do 1s. Pascal's formula is really awesome because it tells us exactly the numbers we would get if we went and solved each of these choose formulas. So how it works is you're going to make your Pascal triangle, and you're going to keep doing these rows until you have the same number of rows as terms. So see here I had 1, 2, 3, 4, 5, 6 terms. So I've made 1, 2, 3, 4, 5, 6 rows. And it is this 6th row that we're going to be working with. Another way to look at this is that if you are expanding to a power of 5, then it's going to be 1 more than that number. Now, all we have to do is match these up with our formula. So 5 choose 0 is 1. Just going to cross this out and put 1, isn't that nice? And 5 choose 1 is going to be 5. 5 choose 2 is 10. 5 choose 3 is 10. 5 choose 4 is 5. And 5 choose 5 is 1. So we've already taken care of skipping out on all of this math that we'd have to do and being able to directly evaluate those. The next thing I want to do is go ahead and simplify anything to the 0 power, because the 0 power always equals 1. So this just becomes 1, and down here, this just becomes 1. All right, so things have already gotten a lot easier. Now I'm just going to go through each of these problems and simplify them down. So for the first one, I have 1 times x to the 5th times 1. So that's just going to be x to the 5th. In the second problem, I have 5 x to the 4th times negative 3y. And I can multiply the 5 and the negative 3 together, so this one turns out to be negative 15 x to the 4th y. In the third problem, I have 10 x cubed negative 3y squared. So, I'm going to write that. So here is going to be 9y squared when I apply that power of 2. So I have 10 times 9, which is 90 x cubed y squared. For the next one, again, I have 10 x squared and negative 3y cubed. When I multiply out the negative 3 times with itself, I get negative 27y cubed. So negative 27 times 10 gives me negative 270 x squared y cubed. 5 x to the first power and negative 3y to the 4th. Oops, to the 4th. So both of those are to the 4th. I could write it like that. And when I multiply out negative 3 4 times with itself, I get positive 81. So this becomes 5x times 81 y to the 4th. And then, oh, this is kind of a big one. We have 5 times 81. Of course, you could pull out your calculator, or you could go ahead and do a little mental math trick here. We have 5 times 80 plus 5 times 1. So 5 times 80, oh, that sounds kind of hard, but when you think about it, it's really just 5 times 8 times 10, right? Because 8 times 10 is 80. So 5 times 8 is 40, times 10 is 400, plus that 5 times 1, so we get 405. And for our last term here, we have 1, the x went away, times negative 3y all to the 5th. So all I need to do here is multiply out negative 3 5 times. And for that one, you might want to pull out a calculator. When you enter it in a calculator, you get negative 243 y to the 5th. All right, so we have found all of the terms. And our last job here is just to sum them all together. I went ahead and wrote in plus signs in between all of the terms, but of course, where I have a negative coefficient, I could have just written a minus sign here, and that's the best way to write the answer. So I'm just going to quickly do that. And it's always a good idea to double check everything before you finish, so make sure that all of your powers on each term add to the degree that you started with, so 5 in this case. And when I do that, I see that I already made a transcription error. So on this one, I have x squared, y squared. That only equals 4. So I know right away that I made a mistake. And yep, when I look back here, it looks like I wrote down a squared here instead of a 3. It's so easy to do on these type of problems, so you always want to check. Let's fix that. All right, so now checking it, I have 5, 4 and 1, 3 and 2, 2 and 3, 1 and 4, and 5. Looks like it all checks out. For more math hacks and shortcuts, make sure to click the subscribe button below. And if you learned something new today, let me know by giving this video a big thumbs up. Till next time, I'm Brett, and thank you so much for joining me.